I only do, I'll just do one of these problems with you to show you what's going on. Okay, so we have the ground. I have a ramp. Okay, so the ramp's at 30 degrees. What force is required to keep a boat from rolling down the ramp? So now we have to put our boat on the ramp. Make it a red boat.
Speedboat?
Yep.
Now, 600 pounds. Where should I draw the line representing 600 pounds? Does anybody know what I mean?
No.
Should I draw the 600 pounds? There's the 600 pounds, when you draw the diagram, should I draw it perpendicular to the ramp or should it go perpendicular to the ground?
You tell me.
What does the 600 pounds come from?
Which is on the right.
Gravity.
What comes from gravity, which comes from the ground. Right? So, 600 pounds is going perpendicular to the ground. So when you talk about physics and you talk about levers and pulleys and all these things that help us do work, as soon as things are on an incline, that 600 pound force is going somewhere else. I don't, if we put Grant under the blue line, like he's the one holding up the ramp, is he going to be holding up all 600 pounds?
Yeah.
No, because some of that force wants to slide down the ramp. That's what makes it easy. So he doesn't have to, right? If we put Spencer over here pushing,
I beat him.
how much weight does Spencer have to push right now?
600 pounds.
Right there. That's Spencer pushing. S for Spencer.
That's Spencer.
How much force does he have to put on the boat to hold it up there? All 600 pounds? Not more than that. Right there? Not all of the boat wants to slide into him, right? Some of the boat is, there's some, can you picture this?
Yeah.
No.
So if the boat is perfectly horizontal, is he giving any effort to hold the boat on the ramp?
Oh, no.
Gravity's going to hold it in place. As soon as Grant starts to lift that ramp, the boat wants to slide back towards Spencer, right? Got it? Until we get it all the way vertical, in which case then Grant is no longer using anything, and Spencer now is holding 600 pounds with just one finger. So,
Spencer died.
I got to write this in here. We have a 30, 90, 60 degrees right there. Can you squish 60 degrees in there? So now when I finish that triangle, I would like to know what X is. And I would like to know, let's call this S for Spencer. 60 degrees. Did you see me when I had the 30, 60, 90? Now, what's that green dotted line? That's perpendicular to the ramp. So X represents, maybe I should use a G for Grant. That was what Grant was holding up. We want to know really what S is.
We don't care about the
What is the force required to keep the boat from rolling down the ramp? So if I do S, it would be 60 degrees. The adjacent is S, the hypotenuse is 600. So that would be cosine of 60 degrees is equal to the S, which is the amount holding the boat on the ramp, pushing it, keeping it from rolling backwards, divided by the 600. What do you get for S? Cosine of 60 is half. So right now, Spencer has to put a 300-pound force on that boat to keep it from sliding off the ramp. Now we're taking out, in physics, any friction between the boat material and the ramp material. G would be the sine of 60 is equal to opposite G divided by 600. So how much weight is Grant pushing up when he's underneath the ramp? How much? 519. I don't think you could do that. So about 519 pounds going into the ramp is what it is. Those type of problems are not on the exam, so you don't have to worry about those on the exam. But, and I'm not doing the next one with you. You guys can. What is it? I should look at the next one. What is it?
It's a try.
No, we're not doing that one either. It's the same type of problem, but okay.
That was a good warm up.